All right, so today we are going to do right rectangular prism and triangular prism. So you will be looking at like the first couple 4 pages, okay? So starting off with a right rectangular prism, this is a solid figure where all sides are rectangles and all sides meet perpendicular. Okay, and I'm going to go ahead and let me spell this correctly first. I'm going to go ahead and sketch a right rectangular prism as well to kind of show you what I am talking about. Okay, now one thing to keep in mind with right rectangular prisms is that they hold the same characteristics as a cube. So I'm also going to make a side note about cubes, is that once again they hold the same characteristics as to if I were to find the volume, they would hold the same formula as well as the attributes. The only difference is that all 6 sides are the same. Okay, so they have the same measurements. The measurements are not going to change. Okay, now when I'm looking at my right rectangular prism, I have a length, I have a height, and I have a width. Okay, this will come into play with our volume because our formula has length times width times height. Okay, now I'm going to go ahead and show you my physical right rectangular prism, because we're going to go ahead and talk about number of faces, number of edges, and number of vertices, okay? Now, starting off with faces, when I'm looking at the number of faces right here, I'm looking at the flat surfaces on each side of my right rectangular prism, okay? So if I look, I have to count how many do I actually have, okay? I have 1, I have 2, flipping on the other side, I have 3, and at the bottom I have 4. Looking at the sides, I also have 5 and 6, okay? So that means that I have 6 faces on my right rectangular prism. Now, also, we have to keep in mind that we want to make sure we're describing these faces, or at least I am. So one thing to keep in mind is that all faces are rectangles. And within the faces, we have a left and right. And those are congruent sides. We have a front and a back, which are your rectangles. Those are also congruent to each other. And the very last, which is our top and bottom, those are also congruent to each other. Okay, so that is a quick kind of definition of what we are talking about, the number of faces. Okay, now number of edges and number of vertices, what we are talking about there is number of edges are going to be where 2 faces connect. Okay, so when we see those 2 faces connect, we're going to see kind of like a line or a crease. And showing you my right rectangular prism right here, I have my 2 faces, and right in the middle, that's where they connect. Okay, so I have 1, I have 2, I have 3, and at the other side I have 4. I have 5, 6, 7, 8, flipping it over, 9, 10, 11, and 12, okay? So that means that I have 12 edges. And with vertices, that's actually the point where all 3 faces meet, okay? So going back to my right rectangular prism right here, what I'm talking about is these points right here. Now, when you're counting the vertices, you want to make sure you're being careful counting them, because you don't want to count them twice. Because if I'm looking at this angle, this is 1 point. But if I look at it this angle, it looks like it's another point, but remember, they're sharing that same point. So be careful when you are counting the vertices. So looking at this, I have 1, 2, 3, 4, 5, 6, and then on the other side, we did not count the bottoms, 7 and 8. So that means I have 8 vertices. Okay. Now, horizontal and vertical slice. What I want to talk about those two things is when we are talking about slices and horizontal and vertical, we're cutting our shape in those directions. So horizontally, remember, is left to right. Vertical is up and down. So when I'm doing a horizontal slice on a right rectangular prism, when I cut that in half, I want to see what shape is given to me on the inside, and that is my answer. So I have fun kinetic sand right here. Okay, when I show you my right rectangular prism, if I make a horizontal cut, which is straight down the middle, okay, and I open that up, what shape do I get? Okay, now obviously this isn't a perfect rectangle, but if I look closely, it is giving me a right rectangle. So my horizontal slice is going to be a rectangle. Okay, now we're still doing the same exact thing, but this time, instead of going in the direction of a horizontal cut, we are going to make a vertical cut. Okay, so going back to my camera, have my right rectangular prism. I'm going to make a vertical slice, which is just me cutting straight down the middle. Sorry about that. And then, as you can see, if I look in the inside, I once again have a rectangle. Okay, now it's a smaller rectangle, but it's a rectangle. So my vertical slice is a rectangle. Okay, and the very last attribute that we have for a right rectangular prism is going to be the net. Now what a net is just me seeing the visualization of the three-dimensional shape into a two-dimensional shape. So what I really want to do is I'm going to want to get my 3D shape and flatten it out. Now what I mean by flattening it out is that each one of my sides are going to be laid out. Okay. And this is a net, okay? So this is your length, your height, and your width. Okay, now obviously this still probably, you're like, what does this really mean? So I'm gonna show you this three-dimensional shape that I have, right? My right rectangular, and if I were to cut along the edges and start unfolding this, I have a net right here. Okay, now it doesn't look like the one that I drew on my paper. That is fine. There are different ways to draw nets. So do you see how it went from a three-dimensional shape to now a two-dimensional shape? Okay, I'll show you at the very top. All right, so that is a right rectangular prism. Okay, now what we're going to go ahead and do is we're going to start solving for volume. So I have the volume formula, which is V equals length times width times height. It's important for us to start not necessarily memorizing, but identifying which equation or formula goes for what three-dimensional shape, okay? Now, this is just, we're taking the same steps, so you want to make sure that you are showing your formula, substitution, your label, and all your work, okay? So my first step here, when I'm looking at example A, is write my formula, which is length times width times height, okay? And then I'm going to start plugging all of these values into my equation. So my length is located at the bottom, which is 14, times my width, which is located on the side, which is 2, and my height, which is the height of this prism, is 3. Okay, my next step is just to start simplifying, which is 14 times 2 times 3. So 14 times 2 times 3 is going to give me a final answer of 84. Now this isn't my final answer because I still have to attach a label. So my final answer is 84 cubic inches. Okay. Now looking at my example B, I'm still using the same formula, length times width times height. Okay, now this is tilted at an angle. That's perfectly fine. You're still looking at the same measurements, and honestly, it doesn't matter where you plug in your numbers because they're all being multiplied. Nothing's going to change. So looking at my length is 12.4 times my width, which is 9, and my height, which is 10. Okay. And that very last step that we take is just to multiply all of these numbers together. So 12.4 times 9 times 10 is equal to 1,116. Okay, now plugging this into my final answer, the only thing that you cannot forget is your label, which is 1,116 cubic centimeters. All right, now moving on to the very last one. I have Tyrone has a fish tank that is 3 feet long, 2 feet wide, and 1.5 feet tall. How many cubic feet of water will Tyrone use if he only fills the tank 2/3? Write the formula, show the substitution, and work label. So first step, formula. Okay, now I have to be careful with this specific problem because the formula that we're using here, that's giving us the measurement if I were to fill the whole entire tank, okay? But remember, Tyrone only wants to fill 2/3. So we have to be careful that we do not stop after we solve for the formula or for the volume, because this formula is giving me the entirety of that right rectangular prism, okay? So I'm going to start off by just finding the volume. My length was 3. My width was 2, and my height was 1.5. Okay, when I multiply all of these together to each other, I have 3 times 2 times 1.5, and that is equal to 9 cubic feet. Okay, once again, this is not my final answer because I still have to find for 2/3 and not the whole entire volume. So what I'm going to do is I'm actually going to multiply 2/3 to those 9 feet, and 2/3 times 9 is 6 cubic feet. Okay, and this is my final answer. All right, so moving on to the very last question for a right rectangular prism. We have Margaret is shipping a rectangular box with shoe boxes. The shipping box is 22 inches long and 12 inches wide and 11 inches tall. Each shoe box is 12 inches long, 6 inches tall, and 4 inches wide. How many shoe boxes will Margaret be able to find in each shipping box? Write the formula, show the substitution and work, and label your answer. Okay, now we're dealing with 2 different boxes here, and because we're dealing with 2, we're going to have to find the volume for both of them because we need to find the volume of the shipping box in order to figure out, hey, how many shoe boxes can I actually put in this shipping box? And in order to figure out how many shipping or shoe boxes I can fit in there, I also have to find the volume of my shoe box because I have to know the measurements of that in order to put it inside of my shipping box. So first thing I'm going to do is I am going to find the volume of my shipping box, okay, which my volume is equal to length times width times height, my formula. Okay, now if I look, it says the shipping box is 22 inches long, so 22 times 12 inches wide and times 11 inches tall. Okay, next step is just to multiply. So I have 22 times 12 times 11. And when I multiply all of those numbers together, I have 2,904 cubic inches. Okay, and I have now found the volume for my shipping box. So now I'm going to move on to my shoe box. I have length times width times height. When I plug in my formulas, I have, or my numbers, I have each shoebox is 12 inches long. That's my length. 6 inches tall, which is my height. But remember, it doesn't really matter where you plug in as long as you're multiplying those numbers. And 4 inches wide. So I'm going to multiply 12 times 6 times 4, which is equal to 288 cubic inches. Okay. Now, in order for me to figure out the actual number of how many shoe boxes I need, or I can plug into my shipping box, I'm actually going to divide the total volume of that shipping box in the total volume of my shoe box to find that number I can specifically plug or put into my shipping box. So 2,904 divided by 288, that's going to give me a total of 10.083 continuing. Now, the only problem is that this cannot be my final answer, because when we go to any store, they're not going to tell us like, hey, you can only have half of that shoebox or 1/10 of the shoebox. You have to buy the whole entire thing, okay? So what I'm going to do here is I'm just going to round to the nearest whole number, which is 10 shoe boxes. So I can fit 10 shoe boxes inside of that shipping box. Okay. All right, now we'll go ahead and start the triangular prism. Okay, now as we are doing the triangular prism, what a triangular prism is going to be, the definition to that is a solid figure with triangular bases and rectangular sides. Okay, so I have a solid figure with triangular bases and rectangular sides. Now I'm going to go ahead and sketch you a triangular prism. Now with this triangular prism, this is going to be with an isosceles triangle. Notice how I said sketch, because this does not look very nice. And then this triangular prism is going to be with a right triangle. Okay. So there are two different triangular prisms. The only difference between these two is that one has an isosceles, the other one is a right triangle. But other than that, there's no different way to solving these. They have the same amount of faces, same amount of attributes, so nothing really changes within that, okay? Now, once again, we're going to do the same thing. We're looking at the number of faces, which are the surface, like the flat surfaces on our three-dimensional shape, our edges, which is where two faces meet, and then we also have our vertices, okay? So let's go ahead and look at my three-dimensional shape. So switching over to my camera, I have my triangular prism. As you can see, I have rectangles, I have triangles. So these are my faces that I have. Now, if I'm counting the flat surfaces, I have 1, I have 2, I have 3, and then I have 4, and then the bottom, which is 5. So the number of faces that I have are going to be 5 faces. Okay, and with me describing what these 5 faces are 3 congruent rectangular sides and there are also 2 congruent triangular bases. Okay, and we're going to go ahead and look at the number of edges. So I'm going to go ahead and camera again. So remember, the faces it's where the faces connect, the 2 faces. So those are my edges, those lines. So I have, let me zoom out a little bit. I have 1, 2, 3. Okay, and then also looking at the base, I have 4, 5, 6, 7, 8, 9. Okay, so I have 9 edges. And we are also looking at the vertices. So looking at the vertices, remember those are going to be the points of my prism. So looking at all angles, remember there are different ways you can look at this prism, but you just want to make sure you are not counting the vertices more than once. Okay, so I have 1, 2, okay, I have 3, 4, and 5, and 6. Okay, so I have a total number of 6 vertices. All right, with horizontal slice and vertical slice, like we did in the last couple of examples, this just means that we are cutting our prism in half, horizontally or vertical. And we're gonna open our shape up to see what kind of shape it's going to give us, okay? So if I go to my camera, you're gonna see I somewhat made my triangular prism. Let me fix that because that looks a little rough. Okay, and with my triangular prism, triangle, somewhat, okay, if I cut it horizontally, straight through the middle, I have to ask myself when I open that up, what kind of shape do I get on both, okay? And if you look, I get a rectangle on both sides. Okay, and that's going to be our horizontal cut because we cut horizontally. Now, if I do a vertical cut, straight down the middle, when I open that up, I now have triangles. Okay, so that is my vertical slice because if I look inside, it is going to give me a triangle. So going back to my notes, my horizontal cut is a rectangle, and my vertical slice is a triangle. Okay, now we also got to think of that net, which remember our net is just making our 3-dimensional shape into a 2-dimensional shape. So if I were to show you and flatten out my triangular prism, here it is, all sides, and cut along the edges, when I open this and flatten it out, this is going to be my net, okay? And I'll go ahead and give you a different view as well. And there's my net. Okay, so that makes this a 2-dimensional shape. So I'm going to go ahead and draw this on my paper as well. Okay, so go ahead and draw this net on your paper. All right, moving on to volume formula. So we are going to find the volume for a triangular prism, whether it's an isosceles triangle or right triangle. Remember, we're still dealing with the same characteristics, so we are still using the same formula for those. Okay, so I have V is equal to 1/2 times base times height times a uppercase height. Now, I know we have 2 H's. The lowercases, what those are going to be represented by, it's the actual base of the triangle. So I'm going to look at my either isosceles or right triangle. I'm going to look at the base, which is B, and the height of the triangle, and those are going to be represented by the lowercase. Now the uppercase H, that is going to be represented by the height of the actual prism, okay, which we'll go over once again in those examples. And then you can either use that first equation that I wrote down or this one. Okay, now they are exactly the same thing. Nothing is changing, just different formatting. Instead of multiplying that 1/2, we're dividing by 2. Okay, so exactly the same thing. You're going to get your answer either way. Now, moving on to the first example, I have dimensions are in inches, so we want to make sure that we are looking that our label is going to be inches. So first step, you always want to make sure you you write your equation, which is 1/2 times base times height. Remember, base of the triangle, height of the triangle, and then height of the prism. Okay, now I'm going to go ahead and bring down that 1/2 because we don't have anything to substitute there. I'm going to substitute the base, which is B, of the triangle, which is located right here, and that is 12. Then I have the height of the triangle, which is located here, and that's 5. And then I have the height of the prism, which is located here, and that is 22. Okay, now we're dealing with an isosceles triangle, just in case you didn't see. So this is an isosceles. Now, my next step, what I like to do first is I like to multiply my whole numbers first before I multiply that 1/2. So I have equals to 1/2, and then 12 times 5 times 22 is equal to that 1,320. Okay, and now I'm going to go ahead and multiply that 1/2 or 0.5, which give me 660. Okay, now this is not my final answer because it is required to put your label. So my final answer is 660 cubic inches. Okay, don't forget that exponent of 3 because we're dealing with volume and 3-dimensional shapes. Okay. All right, moving on to my next one, which is B. This is here a right triangle, so we're not dealing with isosceles, but we're still using the same equation. Now this time I'm going to use that second formatting that I showed you, which is the base of the triangle times the height of the triangle times the height of the prism divided by 2. Okay, now I wrote my equation. Next step is going to be substitution. If I look, I have to look at my right triangle first, and the base right here, remember it's a leg, is going to be 12 of the right triangle. The other leg, which is the height of the right triangle, is 5. And then the height of the actual prism right there is 20 divided by 2. Okay, now as you can see, we still have another measurement. We have that 13. But that 13 represents the side length of our right triangle, which is the hypotenuse, okay? So we want to make sure that we are looking at only the measurements that are in the volume, okay? Nowhere in this volume equation does it or say anything about a side length or the hypotenuse, so you want to make sure you are not entering 13. Okay, now my next step is just to multiply, which is 12 times 5 times 20, which is equal to 1,200. Okay, I'm still bringing down that division of 2 or over 2. And my last step is just to divide that 1,200 divided by 2, which is equal to 600. Okay, and my final answer is 600 cubic centimeters. Okay, all right. Now remember, if I'm going too fast, you guys can move back and then kind of look over those problems again. Now moving on to our story problems, I have a triangular prism with an isosceles triangle, okay, as a base has a side measurement of 7 inches and a base of 12 inches, okay. Then the height of the triangular base is 3.6 inches. The height of the prism is 10 inches. Find the volume of the triangular prism. Remember to label your answer. So I'm first going to start off by just drawing my my isosceles triangle. Okay, it says it has a side measurement of 7. It has a base of 12. And then the height of this isosceles triangle is a 3.6. Okay, now I'm going to draw the rest of my prism. Okay, and then this also mentions that the height of the prism is 10, so that is the side. Okay, now remember, we're only really using 3 measurements in our volume formula. So one of these measurements are not going to be plugged into our formula. So for starting off, write your formula, which is 1/2 times the base of the triangle times the height of the triangle times the height of the prism. Okay. Next step is to start substituting. So I'm going to bring down that 1/2. If I look at the base of the triangle, it is at the bottom. Okay, so I have 12 as a base. The height of the isosceles triangle is 3.6. And the height of the actual prism is 10. Okay, once again, notice how we did not use a side measurement. We're never going to use a side measurement because it has nothing to do with our formula. Okay, now moving on to our next step, we're going to multiply first our whole numbers. So 12 times 3.6 times 10 is equal to 432. Bring down my half. And our very last step is to find the half of 432, which is 216 cubic inches. Okay, all right, and that is the final answer for C. And our last one is a triangular prism has a right triangle as the base with measurements of 3, 4, and 5 inches. The height of the prism is 9 inches. How many cubic feet of space are in this triangular prism? Okay, now we're dealing with a right triangle. We all know when we are dealing with a right triangle and they just give us the measurements, we should know by now that, hey, the biggest number out of these three measurements are going to represent my hypotenuse. Okay, so I'm going to draw my right triangle first before I connect the rest of my prism. Okay, 3 and 4, doesn't matter where you plug them in. The only thing that matters is that you know that your hypotenuse is 5. Drawing the rest of my prism. Okay, it's a little rough. Let me try that right triangle again. Okay, now it says also the height of the actual prism is 9, which is on the side. We're talking about our rectangles side. Okay, is 9 inches. So, writing my formula down first, I have 1/2 times base of the triangle, height of the triangle, and height of the prism. Okay, and then I'm going to go ahead. Second step is substituting. So the base of this right triangle, which is one of the legs, is 4. The height of the right triangle, which is another leg, is 3. And the height of our prism is going to be 9. Once again, notice how I did not even touch the 5. That's a side length or our hypotenuse. We don't need that in our formula. So I'm going to go ahead and start simplifying. 4 times 3 times 9 is going to equal 108. Don't forget your half. And when I multiply 0.5 or half times 108, it is going to equal that 54 cubic inches. Okay, do not forget your label because that is a part of the points that you're getting. Okay. All right. So if you have any questions, make sure to email us or log on Friday for virtual Fridays, and we will help you as much as we can. Okay.